Alright, so we are still now in CLO2, which is learning the elements and processes that are necessary for petroleum to occur in nature in the petroleum system. So you have learned on the petroleum generations, and now I'm going to explain on the mechanisms of migrations, types of traps, a reservoir with the geochemistry input. Okay. Alright, so for the migrations, alright, after generations, the process that will take place in the petroleum system is migrations. Okay, so there are two types of migrations. Okay, we have primary migrations and secondary migrations. So why this migration mechanism has to be known? Simple, because it's one of the mechanism that you need to know once you work under enhanced oil recovery. Okay, so you will need to know all the mechanisms to make any innovations on the methods on how to enhance the recovery of the oil. Okay, so I hope you should be able by right now to explain on the whole concepts of petroleum system. Okay, how does petroleum migrates? Okay, uh, with the considerable evidence, right, suggests that petroleum has migrated from its source rock to reservoir formation, from which it is ultimately extracted. So this migration actually consists of two components: primary migrations and secondary migrations. Okay. So the best evidence of such migrations are the pools in isolated sand lenses, and there are several good reasons for believing long distance migration. Okay, so the media that basically that will help in the migrations of petroleum is porous and permeable sands and sandstone, carbonate sediment rocks, and carbonate sediments. And there also must be a porous and permeable fracture and faults, so that it will help in the migrating of the petroleum from the source rock to the carrier bed. Okay, so primary migration here is migrations of petroleum from the source rock to the carrier bed. Okay, meanwhile for secondary migration, it is actually the movement or the migrations of petroleum from the carrier beds to the traps. Okay. Right, so basically, the present concept of the mechanisms of primary migration is actually suggesting that petroleum globus develop an excess pressure in the pores of shales, and later it will generate the microcrack in the rock through which the globules came out. So once the globules come out, right, the pore pressure will reduce and the micro cracks will be annulled. So meaning that uh, there will be uh, once the petroleum is generated, right, in the source rock, okay, there will be a localized pore pressure that develops, right, together with the increasing of temperature and pressure. So this pressure is actually will cause it will construct, right, the micro cracks in the rock itself. So once the micro crack generated, right, so this petroleum globus will come out, right. So if water containing oil and gas in that rock itself, right, is squeezed out of the clay and shale, right, into the permeable reservoir rock, it must displace the water, means the petroleum must displace the water that is already present in that permeable rock or displacement area. So this will cause a flow of water through the reservoir rock to the surface. So as the water move through the reservoir, right, the entrained petroleum that may be carrying along in a miscible pace, right, until enough petroleum accumulates in the phase continuity to develop buoyancy. Okay, so in general, okay, there are mechanisms that involve during the primary migrations. Okay, either in the oil phase migration or either in the gas phase migrations. Okay, so in general, as the temperature went up, there will be an increase of thermal stress that cause in generations of a continuous bitumen network within the shale ground mass. So the bitumen will then form an oil that later will occupy and impregnated the micropores in the shales and then expel the excess to the adjacent fractures. So any remaining bitumen and retained oil will ultimately carbonize into pyrobitumen, which are visible as the opaque ground mass. So for the oil phase migrations, right, if the TOC is more than 2%, is actually the source rock is from the type 1 and type 2. So it will occur initially as a bitumen. Okay, the oil, okay, it will occur as the initially as a bitumen that absorb water and then expand into the micropores and bedding plane partings or partitions to form a water saturated bitumen network. So as bitumen partially decomposed to oil, right, the latter mixes with gas, mainly methane and carbon dioxide. From the corrosions, it will migrate out as the oil gas mixture. So this mechanism, it is called as the single phase or the separate phase, depending on the pressure temperature condition, right? Then the generation later will cause migrations. Okay, meanwhile, for the all migrations from TOC less than 2%, it is actually the source rock from the type 3. So there will be no or the migration, the conversion is without an apparent bitumen as the intermediate. So the generations and migration of it will take place for the light oil, condensate and gas, right? Okay, so these migrations from TOC less than 2% content is actually particularly for the tight sediments and corrosion type 3. Okay, and it's occur mainly with the smallest and most stable molecules such as methane, ethane, benzene, and toluene. Okay. Alright, next, there will be also gas phase migrations, right, in two mechanisms, diffusion and migration in solution. Right, diffusion is actually a spontaneous or irreversible process in which hydrocarbon move in the directions of lower concentration with a slow in process. So the mechanism basically will take place when the hydrocarbon, okay, will migrated as dispersely in or from lower concentrations, right, according to the type of lithophase. For example, methane and methane, okay, they have a small molecule in size, right? So they distributed through all the lithophase. They has the capability to distribute it throughout all the lithophase. Meanwhile, for propane and butane, right, that has a uh, larger molecular weight, right, or larger molecule size, they only found in the black or gray shells where they were originated. Okay, you have to remember that methane is the simplest hydrocarbon a product, right? So that methane also takes of about 140 million years ago to move vertically, although in a shallow depth of 1,500 meter. Okay, next, gas also can migrate in solutions. Okay, the important, and this is only important for methane. and possibly to ethane, and also small aromatic hydrocarbon like benzene and toluene. Okay, because methane serve as the smallest molecule, simplest molecule, right? So it's easy to migrate in the gas phase, and it also has the higher solubility capability in the pore fluids. As the solubility increase, right? So it will increase in temperature and pressure as well. So therefore, migrating the pore fluids will readily pick up that methane from the source bed, right, and release it during any vertical migrations to the regimes of lower temperature and pressure. Okay. Remember that hydrocarbon that solute and dissolve in pore water will come out from the solution by the changes in increasing in salinity, decreasing in pressure and temperature, partitioning with the oil gas phase, and increasing in gas saturation. Okay. So the primary migration, right, it also has several factors that actually can control the migrations or the expulsions of oil from the, that can control the migrations of oil from the source rock. Okay, the first factor that control the primary migration is the generations of oil and gas. So remember, generation causes migrations because at depth of the oil generation window, there will be localized high pore pressure that originated by the generations of liquid and gaseous hydrocarbon and carbon dioxide. So therefore, there is a force for that fluid to migrate along the bedding planes and through the hydraulic fracture system until they reach pre-existing joints, faults, and fracture, where there is a secondary migration can proceed. Okay, next, mechanical compaction. That is enough to influence my primary migration as well, in which the oil can be squeezed from the shale, but it does not occur in many shale by the time the depth of oil generation reach, because it is only essential and ended in many source rock at depth where temperature exceed 93 degrees centigrade. Water also can help to facilitate primary migration of the oil fields by the increasing of the oil wettability of a shale within a bitumen network. Okay, so it will cause the mix of oil water wettability. So oil will move along the water only if that water occupies about 20% or more than the pores of the volumes. Contains more of the pore volumes. Okay, and then the next factor that control the primary migration is the presence of methane and carbon dioxide. Remember, methane is organic source in which it generated from corrosion within the source rock or by partial conversions of oil to gas. So when it dissolves in oil, it tends to lower both viscosity and density, right? While for carbon dioxide, it is from the inorganic source. So for the source rock type 2, the bitumen form will migrate more readily if carbon dioxide enters the pores because it tends to lower both the viscosity and the interfacial tensions of the oil. Okay, next, overpressure. So if at the peak of oil generation, remember there will be a conversion of organic matter to liquids and gas. So this will create and cause increasing in a net volume of corrosion plus generated fluids. So the volume can increase up to 25% over the original organic volume. So if overpressure of 0.6 to 0.7 psi, that will be sufficient to reopen closed vertical fracture. So there will be parcels of expulsions of oil until generation system runs down. So when generation stops, the primary migration will also stop. So closed vertical fracture can occur after the oil is expelled, and it will open when the pressure build up from the secondary migration. Okay.